Hi guys, we're going to talk about parametric equations when our original x and y equations get a little bit more complicated here. So I want us to always remember how we kind of started with these, and that was just like you probably started graphing anything on a Cartesian plane, just subbing in values. So when in doubt, just pick some values for t and throw them in. But last time we talked about changing our parametric equations right to rectangular form. So I'm actually going to start off with that. So we're going to pick one of these equations. I'm going to use x, and we're going to get t alone. So first, I'm just going to switch x and t, and I'll square both sides. All right, and we actually know some things about this graph if we think way back to chapter 2 in rational functions, like there would be a vertical asymptote at 0, which means x will never be 0. You could graph it, but even just thinking about this, like values you can get out are always going to be positive. So that's kind of thinking backwards here about some values that we'll have for t. So just that to start off. But to finish our rectangular form, we're going to take this and sub it into our original y equation for all the t's. And I got to clean up my fractions. So I'm going to multiply by the reciprocal down the bottom. So we're going to get 1 plus x squared as our rectangular form. And this would be a parabola, right? I'm going to just kind of graph up 1. I'm going to erase that in a minute, but like that's what we're thinking to start. However, I can't just jump to the graph and throw this in. If we're going to graph from the rectangular form, we still need to think about what's true at least for x. So thinking about our domain, we want to think what x values are possible from this guy. Right? And I don't know necessarily that we've graphed 1 over root t, but we definitely know information about the square root of t down here, right? We know that the lowest it could ever be is 0, and then it'll be positive values. But in this fraction, right, we can't have a 0 down the bottom. So t definitely can't be 0, and t is always going to be positive. In turn, that's just going to make sure essentially the same thing for x. We're only going to get positive values out, and we'll never be able to get a 0 out of that fraction. So our domain is going to be x is greater than 0. Now, if you're not sure about that, just try to throw some values into your t-chart for t. So like I always like to start with negatives, and I usually do like -2, -1, 0, right, all the way up. But if I try to put -2 in for x, it's not going to work. If I try to put 0 in for x, it's not going to work. So we're not going to start getting actual values till we put a 1 in, right? If I put a 1, I'm going to get a 1 and a 2 over here, right? If I put a 2 is not great. If I put a 4, I'll get a 1/2 and a 5/4. Or did I do that really off? A 1/2 and a 5/4. No, I think I'm good, right? So notice as our values get larger for t, our x values are actually getting smaller. And I would need to put in some fractions. Like if I put in a 1/4, right, we get better values. But I have a pretty good idea about what my graph looks like. Now what we're going to do is just use the restrictions and things we found out to finish up this graph. So I'm going to erase all this negative side over here. We said x has to be greater than 0. And to show that, I'm going to put an open circle at 0. And then I'm going to throw in a couple values for this parabola. So if I have a 2 for x, I'll get a 5 out. If I have a 3 for x, I'll get a 10. So that's my graph. Now, remember we talked about last time orientation, which is important for parametric equations. This shows as t increases, where is our graph going? So I'm going to use my chart to help us out with that. So when t was 1, my point was 1, 2. So I'm going to write that in my graph. T was equal to 1. Now, when t was 4, my point was 1/2, 5/4. So 1/2, 5/4 would have been right around here somewhere. I'm going to squeeze that in. T equals 4. If I wanted to get this point up here when x is equal to 2, we could use this equation to help us figure out what t was there. So t would have been 1/4. So our orientation is just going to be arrows showing which direction t is going, right, on our graph. So as t gets least to greatest, throw those arrows in there. So I want you guys to try out the next one. You can use Desmos or your calculator to help you check. So I want you to check with that. I'll also post our answer key, and I'll show us really quick, maybe Desmos. I have this one graphed for us. So notice how you put it in. You put it in just like a point, a coordinate, where this is your x equals equation, and this is your y equals equation, and it'll ask you to put in parameters for t. On your calculator, almost the same thing. I already have this graphed here, but I'm going to quit. I'll actually do a quick clear second memory, 712. And then to graph parametrics, you have to go to your mode and change this 1, 2, 3, 4, 5th line to parametric. So I'm going down, choose parametric instead of function. And now when I hit y equals, we'll have an x equals and a y equals instead of just y equals. So let me throw these in here. We had 1 over square root. The x button will now give you a t. T plus 1 divided by t. And there we go. Before I hit graph, I'm going to check out window because this is actually the values. So this one would be okay for us for our graph, but I like to change it so we get some negative values in here for t. T max, I'll do positive 10. It was set for radians if you notice that. So now when I graph, I'm going to see that value. And actually something really nice about this is if you change this little, it's a little line in front of our equation. I'm going to change the line. So moving left and right to these, I think it's those open circles will actually kind of like show the graph as it goes. So let's see if I remember this correctly. Maybe not. Oh, because I didn't hit enter. Let's try one more time. Do this guy, change it to the open circle, hit OK. And now when I hit graph, it's showing me the direction that T is moving. So it kind of shows the orientation on there, which is interesting. So try out the next one, check your answers, and good luck.